Hi, hi. Okay. Hi, wait, huh? Oh, hi. Oh, hi, you and hi. Oh, and you're the only, wow. Limited. Good afternoon, Noel. Good afternoon. Awesome. Hi, May. Hi, May. Oh, and more people. Okay. We're a limited group today. We're gonna get I love that you guys do that. You're like the only class that actually does that, by the way, that actually like talks to each other in that way. But wait, I'm trying to let someone in. Where's Lizzie? Okay. Okay. Um, okay, and give me okay, you can conduct your hot switch. Give me a second, please. 1 second. Hold on. Okay. Um, hi, Lizzie. Oh, okay, now it's getting crazy. Okay, wait. I missed. All right, sorry, I missed. Oh, John said hi. Okay, hi, Lizzie, and hello, Jayla, and hello. Did I miss Eric? Sorry. Hello, Eric. I see you. Okay. Anyway. Oh, I do see. Okay. Hello, Eric. Sorry. Okay. My bad. Okay, so we want to get down to business here. Let me. Okay, this class could either be this. I'm going to warn you right now. This class right now, today, this section, this period could. Excuse me for 1 second. Hold on 1 second. I'm sorry. Yes, I'm coming. What? Okay, another apology. I'm sorry. Oh, and people are here. I'm sorry. Stephanie. I thought Stephanie's in the other class. Wait, what? Oh, wait, okay. Oh, that's the other. Oh, oh my God. I'm sorry. Hold on a second. I'm sorry. Hold on. I'm so sorry, folks. Come. Okay, sorry. Okay, there are some good questions in the chat. I'm going to answer them. I am going to answer them in a minute. And today mostly is about answering your questions for real. Okay. This is an info. This is mostly about, or my goal today is mostly to answer questions or try to ease concerns about the exam, which will be posted tomorrow. So again, I see already that there's some questions in the chat. That's cool. I will answer them. And again, the main point today is to answer questions. Let me just say a couple of things first. Let me just gather my thoughts. Sorry. Okay. Okay. So first of all, and it says this in Google Classroom. I hope this is clear. I probably should ask again to you if it's all clear, but indeed, the exam will be posted tomorrow, no later than 8 p.m. It will probably be earlier than that. Any earlier is just to your benefit. It's not meant to shock you. I'm just saying it'll be no later than 8 p.m. That's when it'll be posted. Then you turn it in via Google Classroom Monday by 12:15. And let me say that again. I know we have class at 3:05. I understand that, but I'm saying the exam is due at 12:15 for all sections, even the section that doesn't even have class that day. Okay, just to, this, and it is the same exam that is going to all 3 sections. That's all on purpose, but it's all therefore the exam is due back by 12:15 Monday. The exam will look very much like the practice exam, but not identical. Any places in the practice exam where I've posted any kind of solution or given you any kind of written solution, then I reserve the right to make, I will change numbers here and there. Like you should read carefully the actual exam. There will be slight differences. Any place I've given you a solution already, then I will expect you to have to think and apply and vary it slightly for the actual thing. Anywhere that I've like given you no solution at all, the question will probably remain identically as it is now on the real exam. For example, almost definitely part 4, although I have some comments to make about it today, and although I have said some things about it to both the other sections, and you should talk with them if you're friends with them. Question 4, I could tell you right now, I'm not going to change it at all. It's, I mean, I will never have given you a complete verbatim solution to question 4. It's a very open-ended, it's a very open-ended question. So you can assume that that will appear as is on the exam. Other questions where I've given you solutions, I will tweak slightly. Okay. And again, I do want to answer the questions in the chat. I just want to make sure this is as clear as possible. Again, whether you know me or not, once the exam is posted Thursday, you can and should do anything and everything you want to continue to make sense out of the material, to learn the material, that is, you can and should talk to one another. Even once the exam is out, you should and can. You can go on the web. You can use the solutions or whatever work we've done on the practice exam. You can use whatever resources you want, and I'm expecting that you will. And you certainly can walk back and forth to the exam and take it under whatever conditions you want. And you should know that I know that you're going to do that. So it's open universe. Consulting other resources to help with the exam is not considered cheating. Doing rough drafts and working things out on paper with other people before you actually make a final copy would be heavily encouraged. But then when you go to make the final copy that you're going to submit for 12:15 on Monday, you are going to write out a final copy that is your work. You're going to know that I know that you could have used any and all resources to get you there. So you're going to know that I know that you know the answers and that you got lots of help or could have gotten lots of help to get you to those answers. So what you're trying to do in the exam is prove to me that you really understand why the answers are the answers. You should think of the exam as more of a project, really, than a test. The project is to show how far you've come with the material. The more details, the more colors, the more diagrams, the more personal, the more words, the more you can make it personal, the more you can think of it almost as like a poster presentation on paper or something, the more you can really show me that you get what's going on, the better you do. And also the easier you can present, the more clear you can present a package, a document that I can easily look at and that where you can make me have to work as little as possible to see that you've worked as much as possible to get an A, the more you'll get an A. or the more likely you'll get an A. A couple more quick details about that. Again, I want to stop talking. I want to get to the test, but I just want to make this clear. I'm I Yeah, actually, I'll talk about that. Yes, thank you for noticing. A little off topic there, but right, that's actually right. Okay, hold on. I appreciate your noticing. Yes, that's true. We'll get to that in a minute or never. But yes, thank you for noticing. I'm glad you're calmer about this. Okay, so the reason I have to be so serious is I am serious about exams, and I know that none of us is perfect, and all of us are sailing into this from different places, and all of that. What I'm trying to say is I'm very loose about a lot of things, but exams are important, and fairness in exams are important. One of the reasons I do all these things about saying you can use open, universe, open, is because I really don't want any one person to have an advantage that other people don't have, especially not an advantage that comes from a willingness to break rules, right? So by getting rid of all the rules, then at least it hopefully puts you all in the same playing field, or more so. To that end, the one thing I have to be serious about, or one last time just emphasize to you, is timing. Once the exam, you can still ask me any questions for the rest of this period once I shut up. And you can text me questions today or tomorrow. You can and should. But once the exam starts Thursday, you can still help all of each other and one another and all that. And you should still and you should still play the videos from the other sections, because I say different things in different sections and stuff like that. But the one thing is, once the exam starts, if you text me, I'm not going to help with your work once the exam starts. You can't text me things like, I did this, this, and this for question 2. Does that look okay? Like, I'm not supervising rough drafts once the exam starts, because that will start being unfair to people that don't feel as comfortable texting me something. Also, it'll drive me crazy. But what you can do once the exam starts, first of all, yes, you can text me if you think there's an error in a question or something ambiguous in a question or something like that. If you think there might be a problem in a question, you could text me about that, and it might be very necessary. Also, and this is the last thing I'm trying to say, this is the main thing I'm trying to say. If you detect even the slightest possibility that your exam is not going to come in at 12:15 on Monday, you absolutely need to text me or email me, whatever. But I want to make it clear, since I'm very inconsistent or soft or whatever about timing when it comes to homework and grading your homework and stuff like that. When it comes to this exam, there may be personal exceptions, there may be personal circumstances, and I'm open to hearing them. I'm actually very open to hearing. I'm even open to hearing individuals tell me that they're having a circumstance that's too personal for them to divulge, or that they can't get a doctor's note for, or whatever. I'm not into any. Oh my God. Sorry, I may have to leave again in a second, but what I'm getting at is, if you detect any reason to believe that your exam might not come in on time, you need to tell me that. Oh my God, I'm so sorry. Hold on one second. I'm so sorry. What's good? Is Mom in the conference? Is Mom in the meeting? I'm very sorry. And this may happen again. This is, seems to be things happening right now. I'm sorry. And I'll look in the chat in a second. Let me just, and I know I want to get to it. I'm sorry. I'm just trying to say, if there's anything that comes up in your life that might make the test come in late, let me know in advance. That is a good reason to text me or email me. Like, and we'll work, and we'll probably be able to work something out. And I probably won't ask you personal questions or like ask for proof. But I need the communication. The one thing I want to make absolutely clear, the two things I want to make absolutely clear is, one, if a test comes in late and I had no idea that that was going to happen, and it comes in with no, a test that just waltzes in late as though that's totally fine and it's not a big deal, and with no acknowledgement that that is an issue, is a major red flag. It's probably the one thing that's ever happened in the past in this class that actually really led to negative and surprisingly large consequences. Okay. Don't be the person that just assumes you can just turn the test in late just because like I'm generally a loose guy or whatever. Don't do that. If there's any chance that the thing is going to come in late, then text me, talk to me, let me know. At the worst, even if you don't have a reason, even if it's just like, oh my God, it's Sunday night and I'm now realizing I don't know any physics at all and I'm totally screwed, still text me. At worst, maybe I'll say, okay, listen, you're going to, for a 5-point penalty, you'll have an hour, you'll have a day extension or something. We'll work something up, but I've got to know in advance before the thing comes in late. Otherwise, I think that you're special and that you don't have to play by the same rules as everybody else. And that's not cool. Okay, anyway, so that's that. So, and bottom line also, once a test comes out on Thursday night, from Thursday to Monday, I'm not saying you can't text me, but I am saying what I won't do is evaluate your work. So if you have any concerns about expectations or if you're unclear about like, what are you supposed to do or something, it's better to ask me than not. Okay. I highly recommend on each one of your solutions, you're trying to be as authentic and honest as possible. You're treating all your blank white paper as though it were a blue book. You are not copying and pasting my questions. You're not on purpose. You're not. You're handing in your own white paper or whatever, but in each part, you're making it totally clear what question you're on, and you're doing the 5-step method one way or another. Like whether you label them as steps or not, you are giving me a thorough solution that starts with the givens, goes through making it absolutely clear what the question is in your words or in your way, gives general principles, and then solves the problem, and then circles the final answer. Like, okay, I think that's all clear. I'm going to shut up, but I'm not trying to make this more stressful. What I'm a little bit distracted right now. That's why I sound this way. But what I'm really trying to say I want to answer your questions. The last class, the last period, and of course you can watch that video and they can watch yours. But in the last video, in the last class, I'm not sure if it was productive or not based on the questions that I answered the questions that I got. I'm not sure if it was productive or not. The one message I want to get across to all of you, some of you find exams more stressful than others. I find them very stressful. I don't want to give you more stress. I want to give you less. I want you to know right now that this method of testing, of giving you open universe and asking you to show me really what you personally know, one of the purposes of that method, I'm talking to all of you right now, is to say, I don't care where you think you are in the physics right now. It's not about how much physics you think you know right now or how much of a physics expert you think you are right now. It's really about how much are you getting out of this class and how much are you growing intellectually, scientifically in this class. Put another way, this test is designed, when I say I want you to prove to me what you understand about the material, when I say to you, I want all the places where you do feel comfortable and you understand to go to town and really, really show me a lot of detail, and the places where you're not so comfortable, the place where you're tentative, then be really honest and self-aware and self-commentating and put like chat in almost and say, this step I don't understand or this or whatever. What I'm trying to say to all of you is no matter where you are with the physics right now, the test is designed so that you still have a chance of getting an A. Like that is the point. You don't have to suddenly become Einstein overnight. I'm not Einstein. You have to give me the most honest, self-aware, authentic demonstration of your physics growth, your relationship to the physics material as you possibly can by Monday. Don't worry about what your physics position is. Worry about what your physics derivative is, if you know what I'm saying. It's about, are you getting to know this material better? That's what you want to show me. Everybody in this room could still get an A. That is my point. And that, even if I'm yelling, that's what I'm trying to get across. Now, I'm going to try to answer questions, I think, for the rest of the period. And I do encourage you to play the video from the other class, like when you're studying, because it's most likely that whatever I did for them is different from whatever I'm about to do for you. Let me just look at the, so I'm gonna look at the chat. Okay. Oh, yeah. Okay. Wait. Oh, okay. Hold on. So okay. Okay. So the first question in the chat is a direct one, so I'm not going to mention the person's name, but I do want to. Hold on. So first of all, just to remind you, I'm putting my cell back so that you can text me questions of whatever kind. Okay, but then also someone's asking about my office. I'm going to put about where someone was looking for me the other day and then couldn't find me, I guess, which I apologize. I'm going to put this in, but it's not going to help you for this exam right now, but I'm putting it in. That's not technically my office. It's technically my, and that may be why you couldn't find where I work on the 4th floor. My research lab is 046105. I can give you all more. It's in a funny place. It's like right near the jaywalk on the 4th floor, like right when you come out of the south elevators, right? When you come out of the south elevators, the elevators near the men's bathroom side, if you make a right and start walking toward the jaywalk, it's the one door that you'll see right before the windows to the jaywalk. In other words, it's in the main part of the 4th floor. It's not in the back with all the labs and all the other offices. It's so easy to find that it's impossible to find. I mean, it's so central that no one ever looks there. That's where I live, but I don't want to deceive anybody. I'm only there these days. I mean, post-COVID, I'm only there on Tuesdays. So it won't, so I apologize. I mean, but you're all welcome to visit next Tuesday or whatever. But yeah, it's the door right next to the window. Yeah, totally. And it says my name. Once you get there, you'll see it's mine. I mean, it's very obviously mine once you get there and look. But yes. Okay, so sorry, but that, which is a totally fair question. And I apologize to anybody who missed me last Tuesday. These days, I'm only there. I mean, because I don't live anyway. Right. Okay. So that's where, but for this exam, please feel free to text me again. I mean, the worst thing that happens is you'll ask me a question that I can't answer, but but anyway, that's my cell. Now also John asked in the general chat, let me make this came up in the other class. Yeah, my ideal, like your exam is, you're using blank white paper. I mean, I would suggest paper that doesn't have lines on it, but that's your business. But you're using blank white paper as a blue book. That is, again, let me make clear to everybody, what you're handing in is not a copy paste of my questions, but you're handing in a document that makes the questions totally clear in your way. Your job in the document is to make it clear what question you're on, make the question totally clear so that I don't have to look at anything else to grade it, but make it clear that you understand the question. That's why I don't let you just copy and paste them. Why you have to put the questions like in your words or whatever is that right away starts to tell me whether you even understand what you're doing or not. So you're handing in on blank white pieces of paper all of the questions as written by you with all the answers as written by you or all the solutions. I keep saying, and then you're scanning it into Google Classroom. Now that somebody asked in the other class, I'm not saying you can't do the test electronically. You could. Some people, very few of us, but some of us are more comfortable just like, or we feel like it'll be neater or more clear if we type into a computer and do everything in a computer. I'm not saying you can't do that. You totally could do that. I think for most people, it's harder. You could totally do that as long as you can figure out a way to do the equations and the diagrams and everything. You can do that, but I just want to make clear to everybody, even if you type straight into a document, still don't type onto my test. Don't take my test and then start typing answers into it. Like you've got to still it's still got to be like Blue Book, like your work, not mine. But also, if you're going to type straight into the computer, make sure that it doesn't look, as they say, sus. Like the one thing about these days about typing a document into the computer is make sure that somehow or other it's clear to me that that's what you have done. I don't want to get a document that I start thinking, did this come straight from Chegg, or did this come straight from a tutor or whatever, right? Now, so just be mindful of that if you're going to type into the computer. But okay, so that answers those questions. Again, now there's things I'm ready to do and go over in this period, like I should have in the other classes, but my main, okay. Oh yeah. Oh, you know what tells you that I hate Chegg? Me. Oh yeah. Oh no. I mean, I don't even, it's beyond hate. I have contempt for Chegg. I mean, this is not the time to get into that whole discussion, but oh yeah, I think Chegg is garbage. And I'm saying it publicly here. I mean, I think it's garbage. I think they should be ashamed of themselves, but, and partly because their solutions are bad. I mean, and often wrong. And then they charge money for them. I mean, but look, we don't have to get into that right now. Yeah, I wouldn't trust them. And their work is spottable. That is the one, again, you can use, don't get me wrong, anybody. I'm not trying to shame anybody. If you have a Chegg subscription, all the power to you. You can use them for help if you want, but I'm saying in the final analysis, when you do this test, you have to do this test. If you use them along the way to learn things, in theory, that's what they're for, then Quark plus America. I just think that they claim that that's what they're doing, and then that's not really what they're doing. People just get solutions from them, pay money, and then turn them in, and they're spottable a mile away. I hope you all realize if you type my name into Google Images, the first thing you see is like 50 like Chegg solutions to my old John Jay homework problems and my old like exam problems. There's Chegg solutions all, and they're garbage. But then people pay money for them and then hand them in, and I don't even have to prove that they're Chegg to take off points. They're just wrong. I mean, so I like whatever. But okay. Questions about, again, there's things I could do. Hopefully you see that what's on the white sheet right now. I mean, the whiteboard is the 5-step method. Just a reminder. Hopefully you recognize that and you know what those things mean. It's a guideline to how to do these things. But, and again, I don't want to waste your time. I've got things I could, I got more that I could say about the exam or the solutions to help you, but I want first and foremost to answer any, like the last period, it was all Q&A. And I think some of it, I don't know, it was either super productive or super not, I'm not sure, but at least people got their needs addressed. So I'm going to pause for a second and let you think if you have any questions like about anything in the practice exam. Again, remember, this exam is going to be very much like the practice exam. So, yes. Okay. That's a very fair question, Zhao Wei. And the answer is yes. Yes. In fact, that is step 2 of the 5-step method. You need to show the question. And yes, you show the question to me. That's right. Yes. Excuse me. Very fair question. Yes. Good one. So good question. More other questions? Can we just wait for a second? Oh, that's a good question. Sorry. Yes, actually. Okay, so John Ford's questions for number 1, D stand, and we can go over that a little bit if you want. It wouldn't be the worst thing. We can go over a little bit, but yes. So John's asking. In fact, I should get my document out. John's asking, in part number 1, and I'm just getting up right now to make sure I don't answer him wrong, but in part number 1, yes, capital D stands for temperature. And that's not meant to be, that's right, D stands for temperature. It's not meant to be confusing. It's because if I use T, that's really confusing because lowercase t already stands for time and capital T already stands for period. So I didn't want to use T. So I'm using D to stand for like degrees Kelvin. So yes, D is a variable that means temperature. That's right. And let me say to everybody, I'm glad he just asked that. Wait, I'm just looking at the chat. Did I miss anything else? Hold on, let me see. Yeah, lowercase t is time. That's right. That's right. So, I will admit right now, that's a problem in the test that I think that very much looks like a homework 3 that we never really went over, which is my bad. But I think but homework 3 and that are very much like an example that we've gone over many, many times. But I'll say this, to be totally honest, that part, which will be on your exam, that part of the practice exam, I don't think I passed out solutions. I didn't go over it in the other section. Like the other section this morning asked me questions about another part of the exam, and then I answered them, and the video is being posted. So to be totally honest, I'll tell you guys, if you don't have a lot of other questions, I'm happy to go over some parts, at least some of the parts of that question that John's asking about. I'd be happy to do some solutions right now to part 1, and it might be beneficial. And then if I were one of you, I would certainly, jot them down, and then I would watch the video from the other class to get the other part that I did with them. I did part 3 with them. And then if I were in their class, in other words, that would be a perfectly good thing for me to do, because then it would just add to the arsenal of your solutions. So yeah, I'm going to actually wait for it sounds like John is saying thumbs up. If there's anybody else in the class that could benefit from me going over a little bit part 1, I'm happy to do it right now. Like that's a perfectly good question to ask about. But I don't want to do it if other people would rather see something else. But so I'm going to pause for a second. It sounds like John's saying yes, but let me just look at is there anybody else that wants to thumb up or thumb down that? Again, I'm here to answer the things that I don't want to waste your time. I'm not going to do something that I think is not helpful, but I feel like I'm losing. Does anybody else have an opinion? Should I go over a little bit of part 1 of the practice exam? I mean, I won't do it the whole time. Is there any, can I get a yes or no from anybody besides John Ford? Am I losing it? Have I lost everybody? Lizzie, help me out. Thank you. Okay. All right. That's good. I didn't need to. Okay. Just because you're alive. Oh, well, John, I know you. Okay. All right. I mean, not to say that other people are not alive. That's like the high. Okay. So I'm going to do a little bit of part 1. Okay. I'm going to do a little bit of part 1. I think it is emblematic of, I think it's a good one. All right. Oh, and I'm even going to do it in these notes. So I'm just flipping pages here. I'm going to do it like on the whiteboard, obviously, but the first notes you'll see when I put the PDF in Google Classroom, the first pages of notes are from the other section where I did a different problem. So you'll have them all in your notes, I guess is what I'm trying to say. So hang on. Okay. Okay, yeah. I'm going to. And I'm going to try, since I think we still have time to this 3:40, even with all the interruptions, I think we're still okay on time. So I'm going to try to do here for everybody, mainly for Lizzie. What I'm going to try to do here, at least for this part 1, I'm going to try to give you a model solution. Like I'm going to try to do this out with the 5 steps so you can see what I'm looking for. Because of course, that's always an issue. It's like, what is he looking for? Then if anything more I do, I'll just like jot down answers. But for this, I'm going to pretend that I'm the student now. Okay, right? So notice I'm saying part 1. So part 1, Okay, I'm about to go on the next page, but just notice right now, I'm just writing the givens, right? That's the first thing you do, like step one, DFP. I'm writing the givens, and notice that I'm covering, I'm trying to I'm the student right now. I'm trying to communicate all the givens that were communicated in the problem, but notice I'm using slightly different words, right? Like I just wrote temperature oscillates in time and is described by blah, blah, blah. That is not exactly what the question says, right? I'm just summarizing it. I'm showing, like using I'm almost like I've read the question enough times that now I can write it out without looking. Like that's a test that right there. The fact that this is just different enough shows that I know what the question is. I'm putting it kind of in my own words, but I'm capturing all the information. Then so I'm still in DFP here. Like I'll even say, this is step one, DFP, diagram and fact patterns. And by the way, I'm not saying you literally have to write step one DFP in your work, but it wouldn't be a bad idea. It's certainly helping me to keep track that I'm writing it down, and it would help you to keep track, and it helps me to grade. You don't have, I'm not going to take off points if you don't literally label it step one, but I don't see why you wouldn't. But it's okay. So I'm in step one DFP. Now I'm still not done with step one, because now, and this is actually another reason I'm glad John's asking about this. Now notice part of DFP of step one is diagram and fact pattern. I'm going to make a little diagram now. Now, please notice, I might have said this the other day. Notice there's no diagram in the question. If you're not paying attention, you might think, oh, there's no diagram in the question, so I don't have to put any diagram in the solution. Oh, no. That's all the more reason I should put a diagram now. The fact that there's nothing in the question. I want to make this as clear as possible, and I want to own this my way. So I put a little diagram. So I'm going to put a diagram here. Okay, so here's my little diagram. It's just a diagram, it's a sketch. But notice it starts to, part of the function of this diagram, it shows me that I know what's going on. I know that this temperature is going up and down and up and down. I know that because that's what that differential equation means. And I know the initial temperature is 150. And I know I'm showing this picture, if nothing else, is showing that I know what D and T stand for, which really is the nature of John's question. It's a good question. So this is a way of defining the constants and variables that are going to be used in my math. I'm defining them right here in my diagram. So this was all part of step one DFP. Diagram and fact pattern. And now it says for question one, okay, now this now addresses Xiaowei's question. Notice now I'm writing the question. Like I've clearly labeled that I'm in Roman numeral 1, part 1, right? It says up top, part 1. Now I'm clearly showing question 1. Maybe I should have even made a bigger deal about that. I'm in question 1 now. and I'm writing out the question. It is not the exact same way it says on the sheet, but it says like find T, the period of one time. Find T, the period of time for one full cycle of values. That's what the thing is asking. It's asking time with a capital T. It's asking the amount of time before the temperature fluctuates back or oscillates back to 150 again. It's asking for the amount of time it would take for the temperature to go through one full cycle of values. That's called period. Like, once you know that's what the question's asking for, it's not that hard to answer. But it's very hard to answer if you don't know that's what the question's asking for. So that's why it's actually a step. That's why it's totally incumbent on you to show me what the question is before you go any further. It helps both of us, okay? But please note, I mean, again, this is Yahweh's question, but it's everybody's question. It's probably one of the places that I'm the weirdest. I'm literally saying to you, one of the rules of my exam is you must make the question clear, but you cannot copy and paste my words. That's a very strange, I know it may feel like a very strange rule, but it's totally because the main reason that people have a hard time answering physics questions is they don't spend enough time actually understanding what the question is before proceeding. Anyway, so this is the question. The question is literally asking for T. That's what the question is asking for, capital T. Right? Well, how can I get it? Okay, well, I know. Well, I'm going to start writing down things that I know. I'm going to start writing general definitions and principles, right? In order to get T, I'm going to start writing things that I know that are true about the period of some oscillator, right? Okay, I'm going to go to the next page here. Again, stop me if you want me to go back. But I'm going to start writing some things that are true about simple harmonic oscillation in general. And then I'm going to apply them to this problem. One thing that I know about simple harmonic oscillation in general is actually, this is even a better way. Here's a better way to say this. Okay, what I'm saying here in general, if anything is described by that second order differential equation, if I ever see that differential equation, d2 blah over dt squared equals negative blah, right, equals negative times a constant times the blah. If I ever see that, that means blah is harmonically oscillating in time. Like anything that's described by any variable, any measurable, any measurement, any dependent variable, any quantity that is described by that differential equation is a quantity, is a measurement whose value is oscillating harmonically in time. What does it mean to oscillate? So first of all, the whole reason I know this is a harmonic oscillation, the whole reason I was able to make that graph initially, right, in my opening diagram is because I see that differential equation. It means SHO. It means harmonic oscillation. But more specifically, and this is where we're about to solve the problem, if ever I see D2 variable over DT squared equals negative constant times that variable, then the rate at which the oscillation is occurring, the constant rate at which the oscillation is occurring is the square root of that constant. Like that is why we call that constant omega squared. So I'm going to say, sorry. So everything I'm writing right now is general truths about simple harmonic oscillation, This is just generally true. So thus I'm going to apply it to this problem. Thus here, okay, so what I'm doing now is step 4, particular application and work. I'm applying the general principles, sort of the triple equal sign, so to speak, the abstract, non-numerical concepts to the particular details of this problem. I'm saying, okay, we have a harmonic oscillator. Definitely for all harmonic oscillation, the rate of oscillation is the square root of whatever the constant is in that differential equation. So the constant here in the differential equation was 625. So the rate of oscillation is the square root of that, which is 25. And by rate of oscillation, I mean, I mean the angular frequency, I mean the cycling rate, but measured in the most direct mathematical way it can be measured, which is to say radians per second. Now we know radians per second are kind of abstract. They're kind of hard for all of us to picture. Why do I care about them? Why am I picking radians per second? Because that's what directly comes out of the math. Like that's the convenience. All I have to do is take the square root of that 625 and boom, I have the cycling rate now. But so I'm like one step away from my final answer to this question. What the question is asking is not a cycling rate measured in radians per second. It's not asking for radians per second. It's asking for seconds per cycle. It's asking me to bring this kind of mathematical way of describing how rapid the oscillations are to a more intuitive, more physical, more experimentally observable way of talking, which is to say, period. So what's the relationship? Well, oh, and sorry, things were happening in the chat. I'm sorry. I was looking at the sheet. I will look at the chat in a second. Let me just finish this, but I apologize. So one more GDP that I can say, and maybe I should have written this up in step 3, but omega equals 2 pi over t, or you could say like I'm saying this a little bit quickly because I want to look at the chat in a second, but look, omega is angular frequency. Omega is cycling rate, but it's measured in radians rather than cycles. What's a radian? A radian is just a 2/π of a cycle, right? There's a radian is basically a sixth of a cycle. There's 2 pi radians in every cycle. So if you want to convert from radians per second to the more intuitive cycles per second, you literally multiply or divide by 2 pi. Again, in other words, if I say to you, this temperature value is fluctuating at a rate of 4 pi radians per second, I know that doesn't sound like it makes any sense. I know that you think like temperature, what does radians have to do with temperature? If I say the temperature is fluctuating at 4 pi radians per second, it sounds like it doesn't make any sense until you remember, oh, there's 2 pi radians to every cycle. So if Yaverbaum says 4 pi radians per second, there's just a mathematical way of saying, oh, like, and then you divide in your mind by 2 pi, 4 pi radians per second. Oh, he's just saying 2 cycles per second, right? If I say 4 pi radians, if I say 2 pi radians per second, that just means a cycle every second. So that's how you convert between omega and F, between angular frequency and standard frequency. But then you can go one step further to answer this question. The standard frequency is measured in cycles per second. This question is asking about period, seconds per cycle, right? So we just want to flip that. If I say something is oscillating at a rate of 2 cycles per second, that means it's taking a ½ second to do every cycle. I'm literally just flipping the number, right? Cycles per second flipped is seconds per cycle. So so putting all together, I'm saying omega is 2 pi over t. So here, so we're almost done. Yeah, we'll pause for a second. Okay, so first of all, I think this is the answer. I think this is the work. And I think I'll just say this, and I'm going to look at the chat. We've got some, I think what I just did was a fairly thorough solution model for just part one of that question. I'm not going to do all the rest of it right now. I mean, we're going to run out of time. I might say some answers for the rest or say some things, but hopefully this is sort of helpful, and hopefully someone addresses John's question. Again, I did other things in the other class, so you can watch the video of the other class if you want to like get more about this practice. But let me look in the chat now. I apologize for keeping you waiting. Oh, right. Oh, good. Wait. Oh, yeah, sure. Okay. Yeah. Okay. Oh, good. All right. So maybe I will go one step further. That's really good. So what John has in the chat, I'm going to correct one word that he has, but I do agree. So, well, for the first part. So he says, so everything I just did is the first part. This is question one. Now, I think when you get to question two, in kelvins, find the temperature at the moment precisely 25 seconds have elapsed from the start. You may round to something like 3 sig figs. When we get to question 2, that's when we're going to do what John Ford is saying in the chat. We're going to use that A cosine omega t thing, absolutely, for the second part, for the second question. And I'll do it quickly right now. I think we have time. Since, again, please let the questions keep coming. Even if suddenly you just think of something right now, if you're listening to me, and you just thought of a question about some other part of the practice exam or something else, even if you don't want to derail this, or even if, like, even just put in the chat so I know, or something, or text me later. But the whole class doesn't have to be about this part, but it kind of will be if no one asks me any other questions. But John's absolutely right. We would use the cosine expression for the next part, and I will. And yes, he's absolutely right that the equation will be something like D equals 150 cosine 25 t. It will literally exactly be that. I'll try to write it in a second. One thing I just want to say, though, is that's not a wave equation. That's an oscillation equation. Just to be clear, the wave equation has t's and x's as independent variables in it. Like the wave equation is y as a function of x and t. This is just x, or in this case, d, as a function of t. But one last fun way, oscillation is a function of one variable, like one input, one output. And the input is always time for oscillation. The input is always time. The output could be whatever, anything, including, for example, temperature. But wave equations, the input is time and space. The inputs are like t and x. And then the output is something else. Generally for us in this class, the output is y. Okay, that's a very important distinction. I'm not trying to be picky, but just to be clear, like this whole exam is trying to bring us from an understanding of the differential equation for oscillation to the differential equation for wave pulses. We're trying to understand in this class that all oscillation is an ingredient, a crucial, vital ingredient to a wave pulse. But a wave pulse involves oscillations in time and space, so that it is more complicated. But yes, to answer to answer question 2 here, and then I'll probably stop with that. To answer question 2, question 2 says, okay, well, I'll say. Okay, so in general, if you ever have that differential equation, and it didn't have to be D's, right? In general, I mean, I could have said Z's, D2Z, dt equals negative omega squared z, then like in general, if you have that differential equation, then that cosine thing is a solution. Now, I might even say, I'm going to finish this. I'm going to, like, if we know that differential equation, right, 2 is just plugging in, and I'm about to plug in. It is just plugging into that cosine thing. But here's the thing. John's not actually giving himself enough credit here. I mean, yes, 2 is just plugging in to the cosine expression. But number one, you have to know that that cosine expression is applicable, is true and relevant here, given that differential equation. So you have to know what you're plugging into. But number two, I was just about to say, notice I just put this asterisk here is a solution. I would highly recommend, I mean, like a lot of the rest of the test is sort of making sure that you understand why the cosine expression is a solution to the differential equation. I would highly recommend that you even take a moment here to show that. I'll show you what I mean. I'm going to answer the question first for your sake. And then I'm going to say, all right, step 3, GDP. If this differential equation is true, then this cosine expression is a solution. So here I'm going to plug in. Right, 20, like both numbers happen to be 25. That's just sort of a coincidence, but it's actually sort of an unfortunate coincidence, but it's true. And now, okay, a couple of quick things. Okay, we have 8 minutes. Yeah, I'm going to read what it says at the bottom. All right. So okay, a couple of things, and we've got 8 minutes. Okay, first of all, so yes, I plug in. I make sure that my calculator's in radian mode. These are all about radians. It will totally make a difference in your answer. But I get like negative 147 as my answer, and that is the answer. Then I just put a note here because I keep. This happened to me as a student. Like the truth of the matter is, I get negative 147. If I were a student, if I were you in this position, and I were really paying attention and really trying my hardest, all that, I might get a little worried when I get this answer. Because if I'm really paying attention to all this and really trying to actually picture it, the truth is Kelvin temperatures can never be less than 0. that's actually weird. And it's actually, in a way, it's actually weird that the whole thing was phrased as kelvins in the first place, because this whole thing is supposed to be fluctuating around zero, but Kelvin. So I would suddenly notice, like, wait, I got a negative. Can that be right? I might think there's an error in what I did, or I might think there's an error in the question. So if worse comes to worse, and the truth is, I really should have made this question. Yeah. Right. So I'm saying, really, I should have made this question Celsius. And the honest truth of the matter is, every semester I forget to change that. That's just my bad. I should have made the question Celsius, and we should assume it's Celsius. And on your exam, I will actually make that correction if I do this exact problem. But I'll certainly correct this thing. But I'm telling you what I would do if I were you. If I got to that, I mean, so I didn't do this on purpose to trick you. It's just actually a subtle mistake. But if I were you and I got to that, if I'm paying attention, I get a negative, when I think about it, if something bothers me, one thing is, that would be an example. If you texted me and said, could the answer to kelvins be negative? If you texted me in the middle of the exam and wrote that, I would welcome that question. Like, basically, you're saying, I think there might be an error in the test. You're allowed to do that. If I think there's not an error, I'll tell you, but maybe there is an error and I might notice it and I might be able to put out an announcement to everybody or whatever. But what I'm really trying to get is worst case scenario, even if you can't reach me or something like that, if there's something that's concerning you, write it into the test. That's what I'm really trying to tell all of you. If you never know whether you're confused or I'm confused, and you don't want to have that stress of confusion in the middle of a test. So I'm saying that's an opportunity. Write it down. Just say, so what I wrote at the bottom here is, note, if these degrees are truly Kelvin, negatives should be impossible. Maybe these should be Celsius. I just wrote that. And I'm saying you can write that as a student. Write a polite, you're not attacking, you're just saying what's in your mind. The more you can give me about what's in the mind, the better for both of us. Okay, so I'm just making that note at the bottom as an example of a note you could make. Oh, also, this is step 5. And I know we're just about out of time. But I also want to say, wait, 5 minutes. But I also want to finish this thought. Notice, but yes, I will, on the actual test, I will correct that. I just keep forgetting every semester. Notice if I go back a page, and again, I know we have like 4 minutes. Notice I put this little asterisk here. I said, then if blah, blah, then D equals D cosine is a solution. So, how do I know that? What do I mean by that? You could literally say this, and you could do this in your test, and I recommend it. I mean, the more you show understanding, the better. What I'm about to write now, this is probably the last thing I'll say for today's class. We have 4 minutes, but I think this is a useful thing, what I'm about to write now, and good practice for all the other questions like in part 2 of the test. This is totally related to that. Why is D a solution to So this is my last thing to say, but look, notice, this is what I just did is what happens a lot in part 2, I think it is. Yeah, part 2 of the exam. What do I mean when I say that the cosine expression is a solution to the differential equation? I mean that if you take that cosine expression, if you assume that D equals, if you conjecture that D equals D naught cosine omega t, if you take one derivative with respect to time, you get d dt equals negative omega d naught sine omega t. Then you take a second derivative with respect to time, and you get, because of chain rule and all that, you get negative omega squared d naught cosine omega t. And d naught omega t is d. So apparently, so therefore d to d dt squared does equal negative omega squared d. In other words, if we pick a cosine function and differentiate it twice, we get back itself times a constant times a negative sign. That's what the differential equation said. So that's why. So the minute we see that differential equation, we know its solution is this cosine thing. That's how it all works. Okay, that's okay. So technically we have 2 more minutes. I don't want to, again, I think, so that covers like a big book. Okay, let me just look. We have 2 minutes. Hold on. I'll tell you right now too, what the answer to question 3, in what units must the 625 be measured? The units of the 625 are radians squared per second squared, right? 625 is omega squared. So it's radians per second squared. The answers are, I'll just tell you the answers right now. I'm not going to explain them, but I'll just tell you so you can know if you're right or wrong for 5, 6, or for 5 and 6. 5, yes, true. It is, given the condition and the differential equation at the top of the sheet, 5 is true. That is to say, even if we added a 14, a phase constant into the parentheses, and you can show it by differentiating twice, it will still work. So 5 is true, but 6 is false. First of all, because 11 is not the square root of 625. And second of all, 99 is not the initial value of D. So to go true, false would be the answer to those questions. So I think but again, if you want to see, so now part 3 was put in Google Classroom, like the solutions to part 3 are put in Google Classroom. Part 2, we talked about the other day. Part 5, we talked about Monday. If you want to see some insights or, sorry, what am I? Yeah, but if you watch the video from the other class, I talk a lot about the middle of part 3 and a little bit about part 4 for what it's worth. And now you just got part 1, so they can watch that. So I hope, feel free to text me or email me with any questions, but I wish you the best. It's not too late for everybody to do well. So I hope you're good. Okay. So have a good, thank you. Yes. Have a GN, have an OG and a GN. Thank you. I'll wait. Thank you. Thank you, Noel. Thank you. Have a good night, Lizzie. Thank you. Okay. Thank you, Yahweh. Good. Okay. Thank you. Okay. Have a nice night too. Okay. I'm just waiting for. Okay. And May, you're okay, or everything all right, or any questions? You good, May? Going once, going twice. Going once, going twice. You all right, May? Should I shut down? I'm shutting down. I'm shutting down. Oh, I'm sorry.